To this third and last day of EclipseCon and the OSDrive track, and we're going to start off with a talk by Balázs Zsoldos. Balázs is the co-founder of a company called Everit, and he's going to now give us a talk called Modularized Persistence. So, Balázs.
Thank you very much. Just give me a second to wire myself up. So, I am Balázs Zsoldos. I work at Everit. I am the head of development there. I would like to present a new way of handling persistent data in OSGI for you today. I really like this slide. I found it somewhere else. It's created by Mark Madsen. I'll talk about relational data. I know that many people says that NoSQL is the only way and everything should be persisted in NoSQL databases. But I think when it comes to real business logic, relations and relational data cannot be skipped out from the system. We've got a roadmap, and we started with Java Enterprise, and after we met OSGI, we started to replace our technology stack because the Java Enterprise solutions just didn't work within OSGI. This step is replacing JPA to a new technology stack. I really liked JPA. First, I migrated JPA into OSGI several times, Eclipse Link and then Hibernate. I found a slide on the internet that others used our solutions that I migrated Hibernate, so I really tried. But I must say on the end that they just don't work together. So we needed a new technology stack that works. And I need a new presenter that works. So I stand here from now on. Or I need a new program that works. Just went out. Sorry for the interruption. This slide killed the presentation. So what do we need in OSGI in order to handle or write SQL statements? How many of you work with OSGI? And how many of you knows data source factory interface? Yeah, a few. So in OSGI, if you want to access a database, you need a service that implements data source factory. This must be done normally by the JDBC driver. And luckily nowadays, all of the JDBC drivers support this interface, or there is an adapter that supports it. So for example, PostgreSQL driver, there is a support from Pax, I think. You can find them. So it's done. What we need is a data source, generating a data source based on this interface. We made a component that can generate data source or XA data source. One thing I love in Java Enterprise is JTA, the transaction handling. It's cool. They made it well. So we can create an XA data source by just configuring via the web console if we drop this component in, or a data source. And this component contains all of the attributes that data source factory can get. Okay, we have a data source, XA data source. What do we need next? Because we cannot use an XA data source directly. We need something that enlists that XA data source and gives us a pooled data source. How many of you use Commons DBCP for any of the projects? Yeah, but you should know about Commons DBCP that there is a version 2 There are many connection pools in Java, but this is the only one that supports really well XA data sources, so it can enlist the XA resource of that data source. And from version 2, it got about 5 times faster because it uses commons pool too. And we created a component for that as well because we would like to create an instance of data source via configuration. So there are many configuration possibilities, about twice of these, just an example. And as you see, the XA data source is targeted from this data source, so they are wired together. We have the DBCP component, so we could directly call SQL statements. But we need something else. When you start up JPA, it checks if your database schema is up to date, and if not, it upgrades it. Do you know any technology that does this except JPA implementations? Well, I saw a couple of them and found that Liquibase was the best to do this. So I really recommend, if you don't even use this stack together, but to check that. Liquibase is based on XMLs, and you can write down your database schema in the way that you can attach changes to versions. So if you have a new version, you can only write down the changes, which is a very good thing. We created a component for this Liquibase. This component simply picks up the data source that is exposed by Commons DBCP or anything else. So all of them can be mixed. And it registers the same data source again as an OSGI service, but with different service properties. Okay? So when that data source is registered, you can be sure that your schema is up to date in the database. Or there will be a failure if the schema cannot be updated. But you can see here is a property embedded data source. And there is another one called schema expression. What does it mean? It points to the Liquibase schema, but where is it placed? The Liquibase schema, I don't know how to pronounce it, looks like this. This is a very simple example that shows a table creation. There is modify table, modify rename column, and many other XML tags. And the idea of the change set, you can have multiple change sets, is the version of the bundle or the persistence or your schema path. And to access this file, you need to provide a capability in the manifest of your bundle. Okay? The capability has a namespace, liquibase.schema, and it has a name. And what we had to provide is the name of this capability. And the capability also must tell where the file is located, the Liquibase XML file. So based on that, the component will pick up this file and upgrade your database if it's necessary. If not, then it just registers the data source. Yeah, I prettified it a little bit just to make it easier to read. We've got a Liquibase data source component. So we can start our business components and use native SQL statements to do updates on the database. But who wants to use native SQL statements? We want to be database independent, I guess. Do you know any technology that gives you the database independency, so you can write like general SQL statements, maybe in object-oriented queries, but not JPA? Which one?
Apache Cayenne, for instance.
Cayenne?
ORM tools.
Yeah, like ORM tools, but without like entity logic or upgrading database schema. I checked a couple of them. I found JOOQ pretty cool, but the license didn't allow to use it with Oracle or MS SQL, only with the open source databases. And there is another one which is really cool, the same, but it allows all of the databases. It's called Querydsl. I really recommend to check this one as well. How many of you used JPA before? Yeah, many. How many of you used JPA criteria API? So object-oriented query. Yeah. So what you will get with Querydsl, JPA criteria API is very good to write type-safe queries, super type-safe queries. But the cost of super type safety is that you write a query and nobody else will be able to read it. I guess you met this before. Querydsl is not that type-safe. You can make a mistake, but it's object-oriented. And others can read your queries, which is a really cool thing. And also, Querydsl supports almost all of the SQL syntaxes. For example, with JPA, you cannot join two tables if there is no foreign, I mean, one-to-many relationships between the tables, which is a big problem when you want to do a left outer join. So this is Querydsl. We found it. Oh. But as JPA has a static metamodel which has to be generated, you have to generate code for Querydsl as well to be able to write these queries. You see these Q customer, Q company classes, they are generated. And with their help, the query can be written. We must generate these. How will we do it? First of all, we must write a liquid-based changelog file. It's done. Cool, we have it. Then we must write a LQMG file. Oh, again, we must write a file. What is LQMG? It's a really small tool that was developed by us. It is basically a mapping between the table names and the class names, between the column names and the property names, because sometimes table names look really ugly. Sometimes foreign key names look really ugly, or column names also look really ugly, but you want a nice code in your Java class that others can read. So this is a simple mapping. We've got the LQMG file. It wasn't hard to write, but where do we say that we have this LQMG file? We add it to the capability. So till now, we listed the resource in the capability, and now we add the LQMG config resource attribute to this capability, and then all of the tools will know about it. Okay? We've got the capability as well, or the LQMG file, and we must add inclusions to our liquid-based changelog if it's necessary. What are inclusions? To show that, I called for help from a project that has inclusions, as you can see it. It's a bit more complex. It's an authorization. It's about authorization. We'll see later if we have time. So it's there, but to help you to read it, it's there. You can include files with liquid-based. You can include other XMLs. And the specialty, we changed a bit the liquid-based code. We would like to contribute it back, that if you prefix with AOSGI, you can point to a capability instead of a file. If you just write a path, then it should be in the same bundle. If you prefix it with EOSGI, then it can be in another bundle, and it can be wired by a capability. So what happens, we've got a project called resource, with a very simple table. It provides a capability. We've got authorization, and it requires that capability. Why is this good? Because they are wired. They are resolved at start time. So your authorization bundle will not even start up. It won't be resolved if that capability is not presented in the system, which it needs. Okay? And of course, it includes in the file that capability. So it's really, really important to know what capabilities are. It's in the OSGI 5 specification. We added the inclusions. And the last step is to generate the Querydsl metadata classes, which is the same as JPA static metamodel. So to do that, there is this tool called LQMG. And how does this tool work? This is a command line tool, but it's also wrapped into a Maven plugin. Probably in the future, there will be a plugin for Eclipse that works together with BND tools, and so you can just generate your code with one push. LQMG first starts an embedded container at the moment Equinox. It installs all of the bundles from the class path. So if, for example, if you use Maven, then all the dependencies of your project. Okay, it starts an embedded HQ database, and based on the Liquibase expression or the schema name, it populates the tables and views. Okay, and in the last step, it uses Querydsl code generator to generate the Querydsl classes from the database, from the embedded database. Well, there is an evil trick there when the modules are deployed, because sometimes you cannot resolve all of your modules with all of your compile time dependencies. For example, if you use SLF4G API in OSGI and someone else uses it, they will be not resolved only if there is an SLF4G implementation as well. So what the trick here is done, if a capability or an import package is not satisfied, then it makes it to be satisfied. I'm not proud of this, but it had to be done to make this usable. So we need use cases, why it's good to have this in this way. Normally, you have a portal with all of the tables, the schema in one place. Yes? And you cannot really reuse your features. If you use module, I cannot pronounce it, the persistence, all of your schema parts, all of your functions are in different bundles, like authorization, authentication, user management, and you can drop this out and bring a new user management with different tables inside. You can upgrade them separately, because if you drop a new bundle in with a new version, it will upgrade only that part of the schema, and then everything will function again. So, but let's see user. When we started to use this technique, we found out that if we want a user, that can be separated to user and address, but because address is a different relation set of tables, okay. And address can be separated to address and country. So the growth of our persistent modules was exponential. We always separated the modules because these columns can be separated, and then a very well reusable functionality can be written on top of them. And then, for example, if you need company data, then it can use address, which uses country. But we need real projects here to see. We have a couple of open source projects that you can already use, and one of them is authorization. So I would like to show the power of this technique via authorization. It comes from experience that there is an open source big document management system that died always when we deployed it, and it was because a big result set was queried from the database, and then for each row a permission check was done. So it was I don't know why they did it. It's a very popular document management system. I don't want to say the name of it. Maybe you use it. And we spent lots of time to replace the authorization logic in it. What authorization does, it needs a resource from the other project. We need the resource project. This resource is only an ID, but it often comes in because we want to have our solutions lazily coupled. If we need some logic to be lazily coupled, then it's a resource, and we wire them together by resources. We have a permission table where an authorized resource can do an action on a target resource, okay? And we have a permission inheritance where someone can inherit from someone, for example, a user group. If a user belongs to a user group, then all of the permissions he gets that the user group has, or if a user belongs to a role, then he gets all of the roles. So you manage these tables as well when you do your business logic. And you find out that with this table structure, you can put permission checks onto your from or join parts, all of them in subselects to everywhere. How? If you write a nice subquery. But it's still faster than querying 1,000 rows and then check one by one, and then show 10 results on the screen. And the authenticated resource IDs that I passed as parameters, these are coming from cache, because if you pass a user in, and it checks which user groups it belongs to and passes all of them as parameters. And on the end, you have a nice query. But it's hard to write this query every time. So yeah, it's hard because there is a function that does it, and it's pretty long with many if statements if there is no, or if there is a authorized user, or more of them, use equals or in the statement. So what you can do, you can call that function and insert into the where part the permission check. Yeah? And your code will be clean. You can reuse the authorization function, and you can write nice SQL statements just in a minute. We have got Querydsl. Do we need something more? I don't like always getting a connection, closing it, handling SQL statements. So we wrote a couple of components called Querydsl support, Querydsl configuration, and SQL templates, which helps us. It's only a very tiny component, all of them, is just to make Querydsl configurable. And based on Querydsl support, you can use functional interfaces to embed your logic. So you don't have to handle SQL statements. You get connection configuration in it. It's similar to Spring has some, I don't remember the name, SQL something. I don't remember the name. It was 5 years ago I last saw Spring. We've got Querydsl support components. It's easier. We have even nicer code. But we need transaction handling. It's done with annotations and I don't know how in every frameworks. But I want transaction helper in the way that it's not wired into this solution. It can be used separately. So it uses JTA. And there is a transaction helper component that can be used as functional interfaces. I think it's much better than use annotations because transaction handling or the technology will not be wired that much to your component model or to your whole solution. You can replace it with a refactor or so. Java 8 is here. Use functional interfaces for this kind of logic instead of annotations. It's much better, believe me. Okay. We've got business logic, but we don't want to always query the database, so we provided 3 components, cache-api, cache InfiniSpan. How many of you used it before? EH-cache, maybe some of you used. It's distributable cache. We tested all of them, stress tested a lot, and InfiniSpan won. So that's why we chose that, but EH-cache could be taken under it, and we created a component where an InfiniSpan can be configured with about, I don't know, 50 attributes, because it's really configurable stuff. So what you do is always you query out data from your database and cache it when if it's not in the cache, you query out and cache it. But there are some rules that you must keep that, for example, you don't update your tables from within different modules. Otherwise, your cache can get easily corrupted. If you need a bulk update, then you expose a service on your interfaces of your model of your bundle to clear the cache. And I would like to list some other open source modules we have. We are generating them one by one. Resource is already there. Yes, it's the central of everything. Authorization is already there. It has a very good performance test. It can handle about 1,000 permission checks per millisecond. So it's pretty fast a permission check, and it also supports this query enhancement. Authentication, we re-implemented, we used Spring Security, Apache Shiro after that, and we found that in OSGI they are too robust. They have too much functionality in one jar, so we started to re-implement. It's like 5 to 10 jars, I don't know, and it's growing. So one of the jar only knows HTTP basic, one of them only knows an form authentication, and all of them are configurable components like configuration admin in OSGI. property manager is very important. Key value pairs in the database. Why? Because, for example, for authorization, system user or system resource is necessary that has permission for everything. So how we do that? We create a resource when this authorization starts and put the value or the ID of the resource to the property manager, and then when we restart the container again and again, we can reuse the same resource ID after that. Authentication also needs a, we call default resource, which is the guest when nobody is authenticated. Okay. Blob store audit, we already implemented it in JPA before, so we are migrating to this new stack. Audit is for auditing data. Blob store, I can guess you can find out what it is. And let's talk a little bit about our roadmap. We found out that it would be very useful to generate HTML from this Liquibase schema, so RQMG and of course the Maven plugin could do that. And I'm sure that pretty soon this schema spy will be used to do that. So when you edit your XMLs, Liquibase XMLs, it's not that easy to read after 3 changes what's exactly done in your database. Then schema spy can help a lot. We need manual schema update because often at companies you don't have permission, your application doesn't have permission to change the database schema, create tables or update them. So there should be, it could be possible to call upgrade database via RQMG or Maven with a separate username password. Also, it should be available via Web Console plugin. You just choose one of your data sources, your system failed, and you can call it with a custom username password. And one more, in banks, you cannot even run anyhow sometimes the SQLs. So just to dump the SQL statement, that should be run on the database, and then you give it to the DB admin, and maybe he will run it in a week or so. And one more thing, this RQMG file, I don't really like it. Liquibase can be enhanced, and within a couple of months, this will extend it, that with special attributes, you can put the namings, class and table mappings, column and property mappings into the Liquibase XML file. Okay. Yeah, and one more, which is my dream. I found someone now who wants to implement it, a PhD guy. Full text search. Many systems work in the way that they query full text index like Lucene. They have 1,000 results, and then they query the permissions one by one for each record, which is hard, even if you use a cache. All of the databases nowadays support a very good, full text searching. We need to find the common parts in them, how they support it. Well, I didn't know how they call it in SQL Server, maybe just full text search index, I don't know. But all of them has, and you can put the full text search index and full text search predicate into your SQL statement. So as we use Querydsl, we need a function, a util function, just to put full text search predicates into your into our statements. Querydsl supports custom operators as well. For example, PostgreSQL uses a custom operator at for full text search queries. So I don't think it could be done with JPA criteria query because it cannot be extended in this way. And create a module and components, of course, for each database engine. Thank you very much. Here are some links about the components. There were many of them. The most important thing that all of them can be replaced. You don't have to use Liquibase or Querydsl if you want to just use the Commons DBCP component or the DSF, Data Source Factory extension component. you can use them separately. Or if you have already a data source because you somehow created that OSGI service, then you can put the liquid-based data source on top. So I wanted to design this whole stack in the way that everything is replaceable. If you don't like something, then don't use it. Use something else. They are wired via OSGI services coming from JDK. The cache uses map, concurrent map interface, so that comes from J. And some more complex solutions. As they are released now, you can check the source of them, so how they work, how they built up. As soon as everything else is released, you can get it via the information via Twitter. Okay, thank you very much.
Tell a little bit about the problems you had with
Eclipse Link. With more robust queries with subqueries, it just didn't generate a SQL statement that was syntactically right. We debugged it for 3 days, then we forbid it to use it because we saw the quality of code inside. I'm really sorry. We created a bug report in their Jira. We really tried to contribute to find the bug, but we saw that for example, some code generation, we was always called 3 times or 4 times, and we had the feeling that somebody who managed the source code was just too confused. So just called again the function, maybe then it will work, or some kind of black box programming was there. I'm really sorry, it's not, just wasn't. And the other thing that we felt that this entity object life cycles, it's not our kind of stuff. There is no such thing in this one. Everything is stateless. You can decide what to store in the cache. There is no L1 cache and L2 cache and stuff like that. For example, in Eclipse Link, if you have a one-to-many relationships, maybe it's fixed now, but if you have a one-to-many relationships and you update it in the way that you update it only from one side, so for example to one-to-many, then it will work in that way that if you query that entity object again, you will see only that way from the other side. You will not see for half an hour, then you will see because it gets out from the cache from both sides. I don't really think, if you don't know the business logic, you cannot really implement a cache for relational data because it's too complex. I wouldn't be able to do it. They did it somehow, but I don't think it's, it's the way. If you know the business logic, you can create a cache in your module or store your. I don't know if you agree, because I was a really big JPA fan before. And I would agree or argue with myself, with the present myself. Sorry?